Hello guys, my name is Prasad and welcome to my yet another video on graphs. So today we are going to talk about adjacency list. Adjacency list is basically a another way to represent graph. In previous video we have seen how we can use adjacency matrix to represent graph. In this video, we will look at adjacency list, and also we will discuss the same set of operations which we performed on adjacency matrix, and we will discuss the time complexity of that. And today also I have created one program. That program basically takes the input of age list and creates the adjacency list out of it. I will give the link of that program in description below, and you can just check it out. You can play with it. You can change that program, and you can just add some operations and just check it out. So yeah, so let us start. Let's discuss what is adjacency list and why does it called as adjacency list. Adjacency list. This is what is adjacency list in front of you, and there are two components to this representation. It is made up of two components. This is an array which you see here. It is an array of lists, and every index position in this array it stores a list of integers in this case. Every index is basically for every vertex in this graph, and if there are n number of vertices in this graph, then the array size will be n, and then every index position stores the list, which in turn stores the neighboring vertices of that particular vertex. So this size of this list will be equal to the degree of the specific vertex. So why do we call it as adjacency list? What does it? Which component of this whole structure, we can call it as a data structure, the whole data structure is making it an adjacency list. So this is not about this array. This array is a simple array, but for every vertex we are storing the neighbors of that particular vertex in the list. Adjacent in the sense, meaning of adjacent is the neighboring vertices. So as we are storing all the neighbors here for that vertex, that's the reason we call it as adjacency list. So in the given input, if you can see, we have 5 vertices or nodes basically in this graph. We have named those vertices with simple integers sequentially. It is 0, node number 0, 1, 2, 3, 4, and 5. So altogether there are 6 nodes, and hence we have created this array of size 6. So index starts from 0 and last index is 5, and every location in this array is storing a list inside it. So this list, so for an example, this location, right, the first location, what does this location tells us? So this location it's for vertex 0, and we are storing all the neighbors of this vertex inside this list. And similarly, on in index 1, we are storing all the neighbors of vertex 1, and so on and so forth. So let us fill out this adjacency list from the given input. And just remember, this representation is for undirected graph. So let us start. So the first edge is 0, 1. So for vertex 0, and the neighbor is 1. And as this is undirected graph, even for neighbor 1, even for vertex 1, the neighbor will be 0. So we will put 0 here. Let's move on to the next stage, 1, 4. So for 1, there is a neighbor 4, and similarly for vertex 4, the neighbor is 1. Third edge is 0, 5. So for vertex 0, there is 5 is one of the neighbors, and for vertex 5, 0 is its neighbor. Next edge is 2, 0. So I will put 0 here, and for 0, 2 is its neighbor. 3, 5. So 5 is a neighbor of 3, and hence 3 is a neighbor of 5, because it is true vice versa. Next stage is 4 and 2. So for 2, the neighbor is 4, and for 4, the neighbor is 2. 3, 4. For vertex 3, the neighbor is 4, and for vertex 4, neighbor is 3. And the last edge is 4 and 5. So for 5, 4 is its neighbor, and for 4, 5 is its neighbor. So now we have our adjacency list ready. And as I said, this adjacency list is for undirected graphs. So what will be the difference? I mean, how we can leverage the same adjacency list for directed graphs. So the adjacency list will be the same, but only thing is, if we have an edge 0, 1, then we have to mark 0 as neighbor. I mean 1 as a neighbor of 0, because edge is going out of 0 and it's going towards 1. But the other way around is not true. So you don't have to mark 0 as neighbor of 1. So that will only be the difference. Other than that, the adjacency list will basically be same. Similarly, for weighted undirected graph, you have to store edge width along with the neighbor. So that will only be the difference.